We're going to be covering exponential growth and decay, essentially word problems with exponents. So the first example, we have a painting worth $200. It increases in value by 13% a year, and how much is it worth after one of those increases? So after 1 year. So we know that the final amount that it's worth is going to be the initial amount that it's worth, and we're going to multiply it by, so we started off with 100% of the value, and then we're going to add 13% of the value. That's kind of a formula for an increase in value of 13%. Or to put it another way, the final value in this case is going to be the initial value, which is $200. And I'm going to write the percentages in decimal, 0.13. So the final value is 200 times 1.13, which is going to be 26, which is going to be 226. So what we have is, we have the initial paintings were $200, it increases by 13%, and it's worth $226 at the end of 1 year. Well, that's well and good. So now we have a painting's worth $200, so same question, it increases in value by 13%, but now it's going to be how much is it worth after 5 years? So what's going to happen is, in this case, the final amount, it's going to be, so after the first year, it's worth 200 times 1.13. That was from the previous question. And then what we're going to do is we're going to take that value, and it's going to increase by 13%. So we're going to multiply it by 1.13. And then we're going to take that value, and we're going to multiply it by 1.13%. Well, by 1.13, which is, again, adding 13%. And we're going to do it another 2 times, because it's going to be multiplied by 1.13 5 times. Or another way of writing that would be the final value is going to be the initial value, which is going to be 200 actually, times 1.13 to the 5. And I cannot do that in my head for sure. So 1.13 to the 5 is that, times 200. And that's going to give us 368.49. When you have money, we're going to round it to the nearest penny unless it says otherwise. So the value is going to be $368.49. Now this kind of lends itself to our formula. So we're going to have just a general growth and decay formula. Growth and decay formula. And so what we see is, we see that generally the final amount is equal to the initial amount and then we're going to 1 plus whatever percentage it's growing by, so kind of the growth percentage, all to the power of 5, and that was the number of times that it grew by that. So to the power of number of times it grows. Well, that's inconvenient to write. So we're going to have some letters. We're going to define some letters. So we're going to say that A is going to be the final amount. And we're going to say that A0 is the emissional amount. So it's the amount at time 0. As a side point, this is usually pronounced a naught, as in British for 0, like naught or nothing. I don't know. But it's a naught. So it's a and a naught. A naught is the initial amount. It's in a kind of cool way. We're going to say that G is the growth rate as a decimal. And we're going to say that N is the number of times it grows. And so our formula is going to be A equals A naught 1 plus G, remember G has to be in decimal, to the N. And that's our generic growth formula. There's nothing special about these variables. I may have made up 1 or 2 of them, but the format is going to be the same, regardless of where you have learned this. So in the next video, we're going to do some examples where we apply this formula.